All right, so we're starting with chapter 9 on sequences and series. This is the first section, section 9.1 on sequences. And at their heart, sequences are really not that complicated. They're just a list of numbers. And so here we have a few examples. Our first example says our sequence is the list of numbers 2, 4, 6, 8, 10. And we can sort of recognize that pattern and realize that the next number should be 12, then 14, then 16, etc. That, like, just by looking at this list, we get an inherent sense that, hey, this is talking about the even numbers, and we can recognize that pattern and fill in the blank. So when a sequence is presented like this is sort of implying that the next few numbers are the numbers you would expect them to be. That said, there's another sequence I can come up with. That would be 2, 4, 6, 8, 10, 12, 14, pi, 18, 20, 22, etc., which is a perfectly valid sequence. But if you just listed the first part, it would be a little ambiguous. When you write it this way, when you write it with this ellipses, ... it's implying something, but it could be ambiguous. So we often use another way of talking about this sequence. So we might say that the direct way of talking about the sequence is, well, this is S1, and then the second number is S2, etc. If we have some way of saying what Sn is, so the nth term, if there's some way that we can write that in terms of n, then we can define our sequence this way. So the first term is 2, second term is 4. We can sort of recognize that the pattern is being multiplied by 2. So if we take our Sn to be 2n, then for any n that you plug in, if we want to know what the 1, 2, 3, 4, 5th term was, we could plug 5 into our little equation, and now it tells us that the 5th term should be 10. Cool. Okay, so looking at example number 2, here the pattern is we've got 1, 2, 4, 8, 16, 32, and if we're sort of continuing this pattern in our head, 64, etc. What we're doing each time is we're multiplying by 2. So the direct way of writing this would be that our Sn is going to be, well, 2 to the power of n. Well, not exactly. If we plugged in 2, or the second term, this would say it was 4, so we're sort of off by 1. If we plugged in 3, this would say it's 8, but that's the 4th term. So if instead we made this 2 to the n minus 1, that would adjust for this problem. So in this case, our Sn would be 2 to the n minus 1. And I also have an example 3 over here. In this video, I'm not going to be working with example 3, though I do encourage you to sort of, as we're going along, think about what each of these steps would be for example 3. When I post this documents, so I'm going to share this OneNote sheet as well as the video. When I post that sheet, I'll have the example 3 stuff filled in, so you can check your answers. Okay, so we've now seen 2 ways of defining a sequence. We could list out the first pieces and imply the rest of them. We could directly write what Sn should be. But there's another way that we could define this. We could use our recursive. So the recursive way of writing this is, we're going to say, all right, the next number should be whatever the current number it is, adjusted in some way. Or sort of more specifically, we might say that, all right, Sn, rather than being defined directly by the number n, it's going to be defined by what previous things are doing. So let's look at our S5. In this case, we've got a 10. Well, we could say, all right, well, how do we get this 10 from the previous number? In other words, what is the pattern, or what is the method of getting the next number? Well, in this sequence, you can get from one thing to the next thing. So we can get from 2 to 4, we can get from 4 to 6, etc., each time by adding 2. And this applies throughout our sequence. So another way of writing that would be that the nth term is the previous term plus 2. So you take whatever you just had and you add 2 to it. So this is good. This is tracking what the pattern is as we go on, but we've got to be a little bit careful. Where we start is actually going to make a difference for what this is. If this was our only piece, then if we instead started at 3, this would be a perfectly valid pattern to follow, but we would get a different sequence. So we also want to specify what the first, or maybe sometimes the first and the second terms are. So we might also say that S1 is 2, and then collectively, this is defining the same sequence. Cool. Really quickly moving on here, with example 2, let's say we want to define our first term to be 1, so we'll say S1 is 1. We may also want to say that the next term that we get, well, the procedure for getting this next term isn't going to be adding 2 anymore, it's going to be multiplying by 2. So we could say that Sn is the previous term times 2. Cool. Okay, so one last way of talking about these is that we could graph them. So we could take this sequence and let's draw this right, and plot these numbers on our x and y. So our x would be our n, basically which term it is. And so this is saying that our first term is 2, our second term is 4, 6, 8, 10, 12, etc. We could also graph this other sequence. And we go from 1, 2, 4, 8, 16, etc. And so we can compare these by looking at the shape of this graph, the shape of this progression.